Hey guys, my name is Tensor. Today we're going to be finishing off the Introduction to Dart tutorial video series by looking at the Dart ecosystem. This means that we're going to look at the Dart tools like the pub tool. We're also going to be looking at the Observatory, and we'll be looking at some of the ways that you can run some tests on your application. So first let's start with the pub command line interface tool. To access pub, you just open up your command line and then type in the word pub. And in this case, I've just added the help flag so that we could see all of the different commands that we can put into pub. You can see here that we have a nice list of commands, though the ones that we really want to focus on in this case are the get command, the global command, and the run command. To show you guys how pub works, I'm going to go ahead and grab a binary called Stagehand, and I'm going to activate it on a global scale. So I'm going to use pub global activate, and then I'm going to type in the name of the binary, which is Stagehand. When we execute the command, you can see here it goes and gets all of these different dependencies, then it downloads them, and then it compiles the executable for Stagehand. If you already have Stagehand installed with your Dart virtual machine, if you go ahead and rerun this command, it will go and update it to the latest version as well. There are various ways that we can access Stagehand. If we want to use the pub tool, we can just run pub global run followed by Stagehand. And this will give us all of the different commands that come with the Stagehand binary. And essentially what Stagehand does for us is it scaffolds out a project. So we can run this command and it will build a simple Dart project for us based on a set of templates, and these are the different templates that we have. So we have a console template, we have a simple package template, we have a server with a package called shelf, then we have Angular, Web Simple, and then Web StageXL, which are all different types of libraries. And you can also go ahead and install a bunch of different generators if you want. So I've gone ahead and I've created yet another folder inside of this playground folder called playground, and then I'm going to run Stagehand, and I'm going to run it without running pub. If it's on your path, you can just directly call it like this. And I want to generate a full console application. So I'm just going to type in Stagehand console full, and this will build an application inside of this playground folder, and it will give the application the name of the folder that it's inside of. So it will name the application playground. If we jump into Visual Studio Code, you can see here we're inside of the first playground folder, and then inside of it we have a new Dart project with a bin folder, a lib folder, a test folder, and then what's called a pubspec YAML. This pubspec YAML holds a bunch of metadata for our project. You can see here we have the name of the project, which, like I said, is playground. Then we have a simple description. This is just scaffolded out for us. So it just says a sample command line application, that we can write whatever we want in here. We can also add a version, a home page, and an author, and these are currently commented out. The environment is in here. Now this environment is based on the version of Dart that you're using. So we're using Dart SDK version 2.1 or greater, but it can't be greater than Dart 3.0, even though Dart 3.0 doesn't exist. Then down here we have the dependencies, which are again commented out. This is where you would put the various different dependencies that you want to add to your project. And then you've also got dev dependencies. These are dependencies that do not get packaged with the application when you go ahead and you publish it. So if we're just going to run the application inside of our command line without actually publishing it as an application, then we will be using these dependencies. Otherwise, we would want to add any dependencies that the application actually needs when it's published to this key up here. Now you'll notice that, of course, a lot of our files are red, and that's because I haven't installed these dev dependencies. So back inside of our command line, I can go ahead and run pub get, and this will go ahead and get all of the dependencies for the project that we just scaffolded out. If we come back into Visual Studio Code, you can see all of the red is now gone because all the dependencies that we needed because all of the dependencies are now installed, and so our application can now find them on our machine. The only real external dependency that we're using for our application is the test suite. So you can see here we're importing a package called test_test.dart, and this is one of the dependencies that is defined in our dev dependencies key inside of our pubspec YAML file. This dependency gives us access to test-driven development, so we can define tests like they have right here, and then we can tell the tests what we want to expect the code to do, and then we can run the tests and see if that actually works properly. Now, to really harness the pub tool, you need to know about this website. This is pub.dartlang.org, and in here we can go ahead and search for various different dependencies that we can add to our project. As you can see here, we have a little search box, and we can choose if we want dependencies that are Flutter specific or web specific, or we can choose just to search all of the different dependencies. So say for instance, I want to find a library that will handle HTTP requests. I can just type in HTTP, and you can see here at the very top we have a library called HTTP, and we can go ahead and find out how to install it by going to the installing tab, and down here you can see that we can just add it to our dependencies key in our pubspec YAML, and then we can go ahead and install it calling pub.get inside of our command line. If we're on Flutter, we can just run flutter packages get, and the Flutter SDK command line tool is just a small wrapper around the pub command line tool. So when you're using the Flutter command line tool, you're really just using the pub command line tool. There's just some small syntactic differences. So going back into our project here, I can come down here and put in the dependencies for HTTP. So dependencies and then HTTP followed by the version, which is 0.12.0 plus 2. And then I can go ahead and save it, go into the command line and run pub-get. And now inside of our project, we can access the http.dart dependency. So I've imported it into our lib folder playground.dart file, but we can also import it into the main.dart file, and we can also import it into our test folders files as well. The general structure of a Dart application is to have a lib folder, and inside of the lib folder you have most of the logic for your application. Then inside of the bin folder you have your main.dart file, which has your main function, which is the entry point for your application. And then inside of the test folder you have any tests that you want to run on your application. Now you don't necessarily have to follow this structure, though I do recommend doing it because it does keep things organized for you. So let's look at an example of this structure. I'm going to take the code that we wrote in the last tutorial with the isolate and the calculate pi function. I'm just going to grab it and I'm going to copy all of this and I'm going to put it into our new project. So if I want to, I can put it directly into main.dart as it currently is, and this will of course run perfectly fine. But if I want to follow the general organization scheme, I want to take this calculate pi function and put it into our playground library file. So if I come into the lib folder and put the calculate pi function in here, I'm going to also need to import dart isolate because we're using the send port object. And then once I've done that, the main.dart file should now have access to our calculate pi function because we're importing playground.dart, which is the file inside of this lib folder. And so we can just call it like we were before, where we're just calling isolate.spawn calculate pi. We'll get a bug inside of our test folder because we no longer have a calculate function inside of our library. And so we could call our calculate pi function in here if we wanted to actually test it, and that would resolve the bug. Or we can just remove this by commenting it out for now. Now if I want to go ahead and run our new project, I can go and run pub run followed by the file where our entry point is, which is currently bin /main.dart. And then when I execute that, it will run like our normal calculate pi application did before, except now we're using the pub tool, which means that we can use external dependencies in this project. Now let me show you guys the Observatory tool. So I'm going to come into our lib folder and I'm going to add a few zeros to our iters value so that the application will run longer. We can still execute our application by invoking Dart directly instead of invoking the pub tool. So I can just run Dart followed by our main.dart file path. But I also want to show you guys the Observatory tool. So I'm going to pass in the --observe flag when I execute this application. And as you can see here, it comes back and tells us that the Observatory is listening on port 8181 on our local host. So we can take our browser and point it towards this localhost 8181 address, and then this will let us open up the Observatory. This is essentially a profiler that allows us to see the various different resources that our application is using. And as you can see here, we have our virtual machine, and then we have the two isolates that are being executed. So we have a calculate pi isolate, and this has a process ID, which is this number here, and then we have the main isolate, which is on this process ID right here. Now, most of the work for our application is being run in this second isolate, so let's go ahead and click on it. And you can see here it shows us the code that's being executed inside of the isolate, and it shows us where in the code's execution the execution is currently going through. So it's currently going through the for loop, and we get a bunch of other information here as well. For instance, when the computation started, how long it's been running for, where the root library is, the isolate ID, and a bunch of other things here too. It also shows us how many threads are being executed. So we currently have one thread of execution for this isolate, and it shows us all of the libraries that are being used in this isolate as well. If we want to, we can also open up the debugger. So I just click here and then click debugger, and then this will open up this. And then we have a bunch of commands that we can execute in here as well, where we can go ahead and rewind through the code if we want to. We can reload the code, refresh it, print it out, pause it. We can execute a log to display some messages, and we can continue the execution, we can clear it, and we can do all kinds of other stuff, which is kind of neat. I'm just going to have it continue executing, so I'm just going to type in continue, and then it should continue executing until it will actually find our pi number. Now there are a bunch of other tools in here as well. So for instance, we have something called the CPU profile, and we can see how much of this CPU is being used by this particular isolate and which pieces of the computation are using it. We've also got an allocation profile, so this will show us how the memory is being allocated. Then we have a heap snapshot, which will show us how the actual memory heap looks like. So here, if I load up the snapshot, we can, let's say, ownership table, and it will show us the different objects that exist inside of our isolate currently. We also have this thing called a heat map, and you can see here that it shows us this graph, and this is a graph of all of the different objects inside of our memory. And we also have a bunch of other tools here, like this metrics tab, this persistent handles tab, which doesn't really apply to what we're currently running. We have a ports tab, which again doesn't really apply. And then we have this logging tab. This tool is very powerful, and it's even more powerful when you have a more complicated application. So while our application only has 2 isolates running, we really can't do much with the tool currently. But if you were to open up, say, like a Flutter application with this tool, you would see all kinds of really cool stuff inside of it, and you'd be able to make changes to make your application more efficient in terms of CPU use and in terms of memory usage. And you could also add things like logging and stuff like that. At some point I plan to make a tutorial which will go into depth on the Dart Observatory tool, but I just wanted to show you guys that it does in fact exist and that it can be useful even if you don't know what every little knob and button does. Before we finish with this tutorial, I'm going to show you guys how testing works on a very rudimentary level. So here I've created two functions inside of our test folder. An add function, which takes in two integers, x and y, and then returns the addition of the two, and then a sub function, which takes in two integers, and then subtracts the two, and then subtracts 1 from the two. Now if we take a look at the scaffold out test, we can kind of guess at how these tests work. So there's a macro called test, which takes in a string, and that's the name of the actual test, and then it takes in a closure, or an anonymous function, which is just the callback that gets executed, and this callback then tells the test whether or not it should pass or fail. So here I've written a test where I'm saying add 5 and 6, and then for the callback I'll just type in expect, and then I'll pass in the actual value, so I'll just type in add 5, 6, and then I'll pass in 11 as the expected value for this add function. So when we add 5 and 6 together, we should get back 11, and therefore this test should pass. So essentially all the expect function is really doing is saying if add 5, 6 is equal to 11, then pass the test, otherwise fail the test. Now the expect function can take in a bunch of other optional parameters. So for instance, we can pass in a reason. So if this fails, which it will because I put in 12 instead of 11, it will throw back this reason where we'll just say 12 is not equal to 11. We can also tell it that we want a more verbose reason. So by default this is false, and so I put in true so that we can see what the verbose reason actually looks like. We just run the test by running pub run test, and you can see here that we get back that it does in fact fail, and it gives us the expected, the actual, and then it gives us back the reason. So 12 is not equal to 11, and then it just tells us that some of the tests failed. Now let's write a test for the sub function, and as you can see here, I can write any code I want inside of the body of the callback. So here I'm defining two variables, one called expected, which I'm setting equal to 10, and then the other one is called actual, which I'm setting equal to sub 3020, and then I'm just adding these two variables into the expect function down here. So now when I run pub run test, our first test passes, and then our second test fails, and then it tells us that the test sub does failed, because we expected 10 and we got back 9. So this is very useful if you want to test all of your logic for your application without actually running the application itself. And there are various other features that are included in this default test suite. There are many people who like to do test-driven development, and it's a pretty powerful way to develop a program. So you basically just write tests and you say, okay, I want this to do this, and then you write your code around those tests until they actually pass, and then you keep iterating like that until you've finally written out your application. There's one more thing I want to show you guys before we close out this tutorial, and that is this GitHub repository called Awesome Dart. Now when you're learning any new language, or when you just want to find resources for a language, just go to Google and type in awesome followed by the name of the language. And there will be a GitHub repository that will have all of the information for that particular programming language. So we have libraries for Dart, we have client-side web app frameworks, server-side frameworks, game development, animation, blah, 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 blah. And then we have the tools for Dart, and we can go and we can take a look. This has the Observatory tool, the Dart2JS tool, and so on and so forth. There are some tutorials here. There's also some links for the community, so you've got things like the Stack Overflow group and the Google group, as well as the Gitter channel. And then we've got the different IDEs and plugins that we can use with Dart. Again, this is a very nice place to start if you want to expand your Dart knowledge outside of the stuff that I've taught you thus far. Also, if you're looking for more information on Dart itself, I do have some advanced tutorials on the channel that you can go and take a look at, and I'll make sure to add them to the playlist after this video. Some of them do sort of overtread some of the information that I taught you already, but they look at that information from a higher level. Also, my hope is that if you've followed this set of tutorials, you should be able to dive into the Flutter tutorials that I have on my channel, and you'll be able to read the code, and if you need to, you can open up the documentation, and that should help you learn the code and learn how to work with Flutter. Alright guys, well I hope you enjoyed this tutorial. If you did, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the comment box below. And if you disliked this video, then by all means downvote it as much as you like. Have a good night.